All right, I'm going to do a quick video here showing you, reminding you how to do circuits. So let's get started. So let me show you. Here is a simple combination circuit. As you can see, it has a part where you're coming out of the battery. You have to go through resistor 1. And then the current splits. Part of it goes this way and part of it goes this way. So this part of the circuit right here is parallel. This part is series because you have to go through it. So if you'll remember the rules, here are the simple circuit rules. In a series, the current's the same everywhere. Voltage drops across each resistor, adds up to the total voltage of the battery and the resistors. You want to find the total resistance of the circuit, you just add them all up. For a parallel circuit, the voltage is the same everywhere. Current splits at each junction, but it adds up to the total coming out of the battery, and the resistors add inversely. So here are our rules down here at the bottom as well. So V equals R, we can always use that. Anytime we have any two of those three, we can figure out the third one. There's only one in that row, one in that row, one in that row, one in that row. So we can't use V equals IR yet. So let's see what we can do. We know that the voltage drop across resistor 1 is 8 volts. And we know that the battery started with 24 volts. Resistor 1 is in series, so if you remember, the voltage drops across each resistor in series. So if I started with 24 volts here, and I dropped by 8 volts here, then all that's left by the time I get to right here, 24 minus 8, would be 16 volts. So I dropped by 8 volts as I went across this series resistor. I'm down to 16 volts. So all that's left in the circuit is parallel. And another rule for parallel is that the voltage is the same everywhere. So if the voltage across this resistor is 16 volts, the voltage across this resistor is 16 volts. So I'm going to have 16 volts across resistor 2 and resistor 3. Now I have two things in each of those rows, so I can use V equals IR. If I want to use the triangle, I can, or you can use algebra. V is equal to I times R. So to get R, I would do V divided by I. 16 divided by 4 would be 4. 16 divided by 2 would be 8. All right. So I also know through this leg I have 2 amps, and through this leg I have 4 amps. So those two legs are two legs in parallel. A parallel rule says the current splits at each junction, but it adds up to the total I. So if it's split into 2 amps through this leg and 4 amps through this leg, before it split 2 and 4, it must have started off with 16 amps. I mean, not 16, 2 and 4 would be 6 amps worth of current. So I know coming through resistor 1, I had 6 amps worth of current. And that came directly from the battery, so I had 6 amps coming out of the battery. Now I have 2 in each of those rows. I have a voltage and a current. Voltage divided by current gives me the resistance. 8 divided by 6 would be 1 1/3. 24 divided by 6 would be 4. So the resistance of resistor 1 is 1 1/3 ohms. And these two are 4 and 8, but when you put them in parallel, it actually winds up being a smaller overall resistance for this parallel part of the circuit. So 1.3, and these two, when you add them in parallel, they must be 2.7. That adds up to 4 for the total.